Hello, this is Module 5. We are looking at Chapter 7 in the textbook, and we're looking at Section 7.1, Algebraic Language and Formulas. And our objective today will be to evaluate formulas and literal expressions. So first, let's go ahead and look at some of the symbols that we use. We are going to refer to parentheses in basically a very broad sense. So each of these different symbols have names, but when we use the order of operations later, and some of you might remember PEMDAS, where it says you do parentheses first, and we'll cover this later in the video, that the parentheses that we're referring to are a number of different symbols that also include brackets, and braces, as well as parentheses. So when we're looking at an expression like what's on here, 3x squared minus 4ax plus 2by squared all to the second power, that should be thought of as an expression, and the expression is in here, and the expression means that there is something and then squared. So that way we will do everything inside the parentheses first, and the expression is all those algebraic letters and numbers. So these are different types of algebraic expressions. So when I'm using the term expression in this class, think of it as basically a collection of letters and numbers that are connected by arithmetic signs, and these signs are operations. So basically, we've got a plus here. So the expression x plus y, we have 2 times x squared. So there's really a times mark in there. Plus 4. That's an expression as well. And when we have these expressions, the number on the front, we'll refer to that as a coefficient. And so it's a coefficient of the expression 3 times x squared minus 2ab. Inside of the algebraic expressions are made up of factors. And so in the expression a times b over here, you have 2 factors. You have a and you have b. And so in the other expressions that you have here, such as 2x times x plus 1, 2x and x plus 1, or you've got the factors 2x and x plus 1. Inside of each algebraic expression, there can be a number of simpler quantities that are added or subtracted, and these are terms. So when we're going to look at this, we've got the first term here, x, and we've got another term, 4y. So the terms are basically the combinations that are used inside of the expressions and that are also made up of factors. So when we look at an order of operations, again, some of you might remember this from before. So PEMDAS, parentheses, and then exponents. So right here, so we got parentheses, exponents, multiplication, division, addition, subtraction. So one of the things I want to make sure to remind everybody is that a parentheses can not only be a parentheses, but it can also be a brace, or it could be a bracket. And so make sure to do everything inside of those these types of grouping symbols before you do the rest of the problem. And then you can do exponents. So the number squared would be an example of an exponent. Multiplication and division, one of the things that's really important is to remember is that these are interchangeable. It can also be do division first or multiplication. It just depends on which one is to the left. So you always work from the left and either do division first or multiplication, or do multiplication and then division when working from the left side of the problem. Same thing with addition and subtraction. It is whatever comes from the left first. So if you happen to have a addition problem first, then you do that first and then subtraction. Or if you're working from the left and there's a subtraction problem and then an addition problem, then you do that. Always working from the left. Let's go and look at a problem that we have here. So this is a problem. Go ahead and do the way that we worked with word problems, and read it first and then reread it and read it until you understand what's there. I'll give you a minute and you can pause it if you need to. Okay, so looking at this problem, we know that we are looking for the speed in miles per hour, what this train is going to, how fast it's going to go. So that's what we're looking for. We're looking for speed in miles per hour, which is a rate. And so let's go ahead then and find a formula that we know is going to work for this. And in this case, distance equals rate times time. And so we're going to try to figure this problem out based on what they've given to us and look for how fast this needs to go, what the rate is, because they've given us the distance here, 400 miles, and we know the time. So we're going to substitute those, but before we do, let's look at the time here. They're giving us time in 2 hours and 40 minutes, which is hours and minutes, and the rate is in miles per hour. So we need to get this down to a common denominator that we can use to cross both, that we can use to divide later on with. And so instead of trying to put this into minutes, which can complicate the problem, we're going to go ahead and put this into a fraction of hours. And so we'll look at this as a fraction of an hour, and we know that we have 2 hours and 40 minutes over 60 minutes. So looking at just the 40 over 60, let's reduce that down. And we're going to say, okay, that is, let's see, take off the zeros, divide by 10 on both of those, divide each of these by 2. And we can say we've got 2 and 2/3 of an hour. And now, making this into an improper fraction, we're just going to multiply 3 times 2 is 6, plus 2 is 8/3 of an hour. So now, when we go to work with our problem and try to figure out what the speed is in miles per hour, we have a number that we can work with. So let's go back and look at this again. So this problem is distance equals rate times time. I always like to rewrite my formula just because now I'm going to work on substituting. So let's go ahead and I'm going to substitute in 400 for the distance. The rate we don't know, so we'll leave that as R. And we do know that the time is 8/3 of an hour. Now, we're going to go back to working with what we've done before, and that is isolate the variable. In this case, and we're going to isolate the variable R, and by doing that, we look at it's being multiplied by 8/3. So in any of these problems, remember the trick is to do the opposite operation. So if 8/3 is being multiplied by R, then what we need to do is we need to subtract 8/3 from R. And of course, what we do to one side, we have to do to the other. And then this is going to be a little bit of a reminder for some of you. We're going to need to remember that whenever we are dividing by a fraction, we need to multiply its inverse. And so in this case, this problem will become 3/8 times 400 equals r. Because what we're doing is we're multiplying that 3/8 inverse here, and that takes and makes that 1, just like we did before. And so let's use that as a capital R. So now we're going to multiply straight across here. 3 times 400 is 1200 over 8, and that equals R. Get our handy dandy calculator, and 1200 divided by 8 equals 150. So we will say that R equals 150 miles per hour. So, does that answer the question? How fast it needs to go? Yep, absolutely. It needs to go 150 miles an hour. Don't know if I personally would want to take it. It seems that's awfully fast. So let's go ahead and look at how to do temperature conversion. It's going to be really similar. You're going to just need to substitute in either the Celsius or the Fahrenheit into the problem to be able to solve it. And these are the formulas that you're going to use, so you might want to just have those handy for any problems that you have for temperature conversion. Go ahead and we'll solve this. If we want to set this problem up, we want to convert 85 degrees into degrees Celsius, and so we don't know what C is. That's what we're looking for. And again, rewrite the problem. 5 times Fahrenheit, and in this case, Fahrenheit is going to be 85 degrees, and so 85 degrees minus 32 over 9. And so we want to make sure to follow our PEMDAS, and the order of operations says that we will subtract first. So 85 minus 32 gives us 53. And so that says we're just going to bring this problem down. 5 times 53 over 9. So now PEMDAS says do multiplication and division. In this case, we want to get the 53 out of the parentheses. So we're going to go 53 times 5 equals 265. And then that's going to be over 9. And then 265 divided by 9 is 29.4 degrees. Celsius. Alright, that's the end of this lesson, and we will do 7.2 next.